Okay, so today I just want to solve this problem and then actually we are done. So this is under the title of Applications of Derivative, that is Exponential Model. So I think this is a very good example from Matematik Origo book 3. So I have chosen this example exactly from page 104. So let me read the question for you first. So the value of a collection of antique coins purchased 8 years ago increases exponentially with time. The purchase price was 23,000 crowns, and now it's worth 27,000 crowns. Okay. Part 1 of this problem: determine an exponential function that describes the value increase of the coin collection over t years. Okay, and the second part, at which time the value increases by 1,000 crown per year. Okay, so let me see how we can solve this problem. So it is mentioned in the problem itself that the price increase follows an exponential model. Yes, it is mentioned in the problem itself here that increases exponentially with time. So it means that the model that we are expecting is something like this. If P is the price, I'm just changing the letters here because we are talking about price. Instead of calling the function f, it's better to call the function p. These are minor differences from the book. And now, because our variable here is time, and it is also mentioned t here, so let me choose that variable t. So this is the price of this collection of antique coins at time t, where t is expressed in years from the time that we have purchased this antique collection. Yes, it is telling you that this follows an exponential model. So an exponential model that we have is in general a function like this. You have a c here, a constant, and then you have, it depends what is the base of your exponential function. It hasn't mentioned anything, so in general you can take it any positive value except 1. And then you have this to the power of some number k, which we don't know, multiplied by t. So this is when you say a function follows an exponential model. In general, this is the meaning that you need to understand. So it means that the function describing this model has this form in which c is a constant, k is a constant, and a is also a constant, but not positive and not equal to 1. So it should be positive and not equal to 1. Of course, if I ask you what is c, hopefully you remember. So if I write p of 0, what will happen? It becomes c, a to power k. I need to replace t with 0, but this becomes a to power 0. It becomes 1. When you multiply it by c, it becomes c. So if someone asks, what is the interpretation of this constant? You would say that this constant is the value, is the initial value of the function. So you see, c is the price at time t equals 0. So that is the initial price, okay, in this problem. So it is the initial value of your function. So interpretation of this c is clear. But you might ask, okay, how by the way, if I want to make this model clear, I need to find the values for c, a, and k. Because if the model is going to be clear for me, it means that I need to find the values for c, k, and a. Then my model is clear. Yes. There are some information provided for us in the example itself. I have to use them to find these values. But what I am telling, exactly according to the book, it's always easier if you want to work with the exponential model, choose the base to be the Euler number E. Okay, especially when you are dealing with derivatives and a rate of changes. Yes, so here I am interested in finding the rate at which this price of this collection is increasing over time. So it means that you probably immediately understand that you need to work with derivatives of this model. So it is always easier to take this A to be the Euler number E. Okay, so you might ask, okay, how do we know that? What I'm telling you is that it doesn't make any difference in the calculations at all. You can choose A to be 2, you can choose A to be square root of 3. As far as you choose A to be a positive number not equal to 1, the final answers that you get are exactly the same. Okay, let me tell you why this is the problem. So in principle, any exponential of this form can be written of this form as well. So any exponential with base A can be written as an exponential with base E. It can be written as an exponential in any other base. This is always true, okay? So for example, let me write this and then I will clean this. For example, if I have a to power 2 to power x, this is an exponential whose base is equal to 2, okay? But this can be written as e to power x ln of 2. Is that understandable? So let me just repeat this. Some might be you have forgotten why these are the same. Because e to power x multiplied by ln of 2 can be written as e to power ln of 2 and then to the power of x. Yes, I have an exponent, I have a power, I want to exponentiate it once more. So the rule is to multiply these two numbers and I will get this back. But if I ask you what is this inside the pair of brackets, that's an important formula for e. Yes, do you remember? E to power of ln of any number is that number. Okay, so it means that e to power ln of 2 is nothing except 2. So if I continue, this becomes 2, and then I will have to power x. So you see that this formula that I was claiming is correct. I started from the right-hand side, and I got what is on the left-hand side. So what is happening now? Here, if I ask you what is this, you would say that this is an exponential function whose base is 2. Okay? If I ask you what is this, again, you see that this is an exponential function, but the base is the Euler number E. Yes? And of course, the price that we are paying for changing this base is that we have an extra constant on top of that. Yes? So if I name this one, if I call this one K, then this becomes e to power k times x. Of course, this k is a particular value, okay? So this means that you see that any exponential function, for example, I have chosen the base to be 2. It doesn't matter, you can choose any number that you like. Any exponential function with base 2 can be written as another exponential function with base e. So it doesn't matter. In Math, if I remember, it was Math 2C that we were talking about exponential models, or Math 1C, I don't remember exactly right now. But we always worked, so in those problems, this A were given to us directly, so we started working in those bases. But now, here, we have only the information that this model is exponential. That is up to you to choose this base, what you want to choose for this base. What I am telling you, I am recommending you in these problems, when especially you're dealing with derivatives and rates of change. So it's better to take this, the Euler number. The reason is that the derivative of e to power kx is k e to power kx, but the derivative of a to power kx is k a to power kx, but if you remember, multiplied by an extra ln of a. So the form of the derivative of this exponential function is simpler than the form of the derivative of this exponential function. Okay, so the only difference is that it becomes simpler to calculate things, but it really doesn't matter what you choose for the base. This is not explained very well in the book. They say that we choose the base to be e, but this question might come to your mind, that why I should choose e. My answer is that it doesn't matter. For example, at which time the value increases by 1,000 crown per year, it doesn't matter if you model with base e or if you model with any other base. The answer, the final answer that you will get for part B, for example, is exactly the same. That is what I want you to understand. This is not explained very well in the book, okay? Of course, I will come back to this. So let me go back here and try to solve this problem. Okay, so any questions so far? Is that understandable? Okay, so now this is why instead of this one, I will write P of t after this long explanation. I will write P of t c e to power kt. Okay, so I will start from here instead of starting from this model. I am choosing the base to be the Euler number. Okay, now let me read the question again and use this information to see how this goes. By the way, is my picture preventing you from seeing what is behind it? Yes or no?
No.
No, so you can see everything on the screen?
Yes.
Okay, thank you. Okay, so here, the value of a collection of antique coins purchased 8 years ago increases exponentially with time. The purchase price was 23,000 crowns. Okay, so what does it mean? It means by reading this sentence, I realize that the price, the initial price, the price when time is 0, is 23,000 crowns, yes? This is what I understand. So as I explained before, this means that this C is 23,000. Yes, this is the initial price. Let me explain again. If I ask you what is P of 0, you say that this is C e to power k times 0, but e to power times k times 0 is just 1, so it becomes C. So there is no difference between C and the initial price. Because the initial price is given to be 23,000, so it means that C is 23,000. Okay, so the model is a little bit now more clear. So P of t is equal, instead of C, I put 23,000, and then I have e to power kt. I have another piece of information. I know that after 8 years, the price is now 27,000. So what does it mean? It means that price after 8 years is 27,000 crowns. Why this information is provided for me? Because still the model is not completely clear, yes, because k is not known. This extra piece of information is given to you to be able to find the value for k. Okay, so I know this, I know this. So let me, if I ask you what is P of 8 from here, you know what to do. You just replace t with 8. So it becomes 23,000 e to power 8k. So on the one hand, P of 8 is this. On the other hand, P of 8 is given directly to be 27,000. So these two values should be the same because they are expressing the same quantity. So this means that 23,000 e to power 8k is equal to 27,000. Okay? And if you remember, we talked about these kind of equations before. Yes, this is an exponential equation. Why? Because my unknown is in the exponent and I want to find that. Hopefully you remember that lesson. So the first thing that I do, I divide by 23,000 both sides. So it becomes e to power 8k is equal to 27,000 divided by 23,000. Okay, and then if I simplify this by 1,000, it becomes 27 over 23. Okay, do you remember? I want to ask you, how can I find this k here?
You take the logarithm, right?
And logarithm in which ways? Did you study anything during these 3 weeks? Yes, I have to take logarithm, but in which base?
You take 8k to be equal to 27 over 23.
To what?
8k equals 27
Yes.
over 23.
No.
To the ln of 27 over 23.
Yes, that's the crucial. Yes. So 8k is equal to the, so you said logarithm is correct. When I said in which base, you should say in base e. Do you remember what was the ln? Ln is the logarithm in base, in the Euler base, yes, which we called it in the natural logarithm. And instead of showing it with log, we just show it with ln. Okay, in the book, this number is calculated, but let me keep it exact, yes? Okay, and then if I ask you what is k, you find it, yes? So k is equal to 1 over 8 ln of 27 over 23. So this is the value of k. Okay, so let me keep it like this because it is a big number. Let me keep this k, but we know the model. So everything for my model is now clear, yes? So if I ask you what is p of t, you will say that p of t is 23,000, yes? And then e to power kt, but let me keep it exact. In the book, they have put this in the calculator, so they have got this number. 0.020. Okay, so this is the number that they approximately get for this one, and then they replace this with this number. But I want to keep it exact, so let me just write k, but let me mention that this k is this k here. At the end, I will consider that. So if I ask you, is my model clear? You would say yes, because everything in the model is determined now. So part 1 of the problem is finished. Determine an exponential function that describes the value increase of the coin collection over t years. This is this, where k is exactly this number here. Okay, now let us go to part B. In part B, at which time the value increases by 1,000 crowns per year? So how do you interpret this? I want you to understand that this is related to the derivative because it is related to the rate of change of something. Okay, we are interested at a time at which the value increases. This is the rate of change of the price by 1,000 crowns per year. Okay, so if you read this sentence, I hope that you understand for part B, this is the question, at which time, so t is unknown, the price increases by 1,000 crown per year. It means that the derivative, the rate at which the price is changing, is the derivative is equal to 1,000 crowns per year. So when you read this English sentence, you should be able to translate it in mathematical language in this way. Is there any question that here? Do you understand this?
Yes.
Okay. Now, It is very clear. So it means that I have to take the derivative of this function, p prime of t, and equate it with 1000, and then I can find my value for t. But if you remember, the derivative of this function is what? The derivative of this function, you remember 23,000 is just a constant, but this k will go down, so it becomes k, and then I have to repeat my function. So let me remind you of the formula. E to power kx prime, k goes down, and then you repeat your function. The only difference here is that instead of variable x, I have variable t. So hopefully you understand that this is the derivative of p. Now, on the one hand, p prime is this from our previous knowledge about the derivative. On the other hand, it is given to be this. So this means that these two expressions, these two values should be the same. So it means that 23,000 k e to power kt should be equal to 1000. Let me ignore the units for the time being. But if I ask you what is unknown in this problem, don't get confused. The only unknown is t, which is wanted in the problem because we already calculated k. Okay, so if I want to find this, I divide everything by 23,000 k. Then what happens? It becomes e to power kt is 1000 divided by 23,000 k. But I can simplify that by 1000, so numerator becomes 1. The denominator becomes 23k. Okay? So let me go to the other page to solve this one. Again, I am telling you, if I ask you, is it a known number? Yes, because k is approximately this number. You can plug it here and find the answer. K is also known. Then you need to find this t. So let me take this on with me. So let me go to the other page. So I have e to power kt is equal to 1 over 23k. On the other hand, k is equal to this number, 1 over 8 ln of this. Yes. Now I want to find t this time, but the trick is the same. Yes. What should I do? I take ln, so this becomes kt is equal to ln of 1 over 23k, and then what is t? T is 1 over k ln of 23k. So that is the value for t. But let me put everything. If I want to find the exact value for k, I need to work with that one. Of course, it is a little bit strange relation. This is why the book has used the approximation values, okay? But then this becomes 1 over 8 ln of 27, 23 ln of 1 over 23 times 1 over 8 ln of 27, 23. So you see, if you don't want to approximate, it would be a little bit fancy to write it down, yes? Of course, I can make it a little bit more beautiful, but not that much. So this becomes 8 over ln of 27 over 23, and then you have ln of 8 over 23 ln of 27 over 23. Yes, I hope that I am not confusing you. So don't worry about this. The calculator will be allowed. So it means that from here you can calculate k. According to the book, k is approximately this value. So it means that here, when I want to write my model, I don't write k like this. I just write 23,000 e to power 0.02 t. This is your model. Might be working in this way is easier, but of course, this is an approximation to the real model because 0.02 is not the exact value of k, is an approximation to the value of k. If you decide to keep it very exact, of course, the price that you pay is that this is the year, yes? Okay, so the unit, of course, you need to write years, yes? Yeah, so this is T, the unit is year. Of course, at the end, you can do the approximation. I don't know, is your calculator available? Can you calculate this using your calculator? If you have done it correctly, you should get 39, if I haven't done something wrong. So it should be approximately 39 years. The year 39. The price would be 1,000 crowns. So if you wait 39 years, then the price of this one that you have purchased will be increasing. If that model will work until 39 years, then of course, every year you will expect 1,000 crown increase for the collection that you have. Any questions? Yeah, that's a good exercise to put this number in your calculator to see that it will work exactly 39. So if I want to just review a little bit, is that the problem is mentioned that this model is exponential. Usually when you have an exponential model, you have a formula like this where C and K are not known. And A, what I described is that you can choose whatever you like, okay? It doesn't matter at all because exponential with any other base can also be written as an exponential in the base E. So if you are, but I am recommending you not to do this. When you see exponential model, choose the base to be the Euler number, especially when you are dealing with derivatives and rate of change, because when you are dealing with derivatives, the derivative of exponential function whose base is E is easier than working with an exponential function whose base is A, okay? And then this number C has an interpretation that is the initial value of your model. You and read the problem once more to understand what is the initial value, put it there. And then you need to find the value for K so that your model is clear. If you read the problem, there definitely will be some information in the problem so that it will help you to find that K. And usually these problems have more than one part. The first part asks you to complete the model. And then when the model is completed, it means that you found C and you found K. Then they will ask you a question regarding your model, okay? Then you need to use the formula that you found for your model to answer the second part of that question. So that is the general form of these kinds of questions. If you want to, I recommend you to, for example, solve the same problem, but take A to be 2. Okay, for example, or if you want, take it to be 3 or any other number. And do the calculations and see that the answer, for example, to part B would be exactly the same number. Of course, the number would not be of this form. It would be a logarithm in the base 2. It will deal with logarithm in base 2. But if you calculate that number, you will get exactly this number that we get here. So this is independent of the choice. This calculation is independent of the choice of this base. Okay? Any questions?
I have a question. Will absolute values be on the test?
Absolute values. Let me stop this and then I will answer your questions. If you have any questions about this problem that I solved, please let me know now. Okay, so if you don't mind, let me stop.